Hi everyone, this is your introduction to lab number 7. It's just called normal problems. So in this lab, we're not doing anything special. Usually in labs, we see an interesting application of what we're learning. Not the case here. For this chapter, I wanted to just give you guys just problems to practice, and then there'll be one extra element to most of these problems when we calculate these probabilities. So the types of problems you'll see in this lab, they're really just homework style questions, lecture style questions. These are the kind of questions you're going to see on your exam. So, nothing all too creative or exciting application wise. But there is one extra piece to most of these questions that we really haven't discussed specifically. So I want to highlight that. And that is for most of these at the end, after you calculate a probability, it's going to say draw, label, and shade a bell curve to depict the probability. So I just want to let you know exactly what I'm looking for when I say that. So I've got an example right here. We'll do two of these, and hopefully that will be clear enough what we're looking for. So let's say, for example, you had a problem where the mean was 19 and the standard deviation was 5. Okay, so I'm just telling you these numbers. Usually we like it in some kind of a context to make it interesting. But let's say we know that mu and that sigma, and then the question said find the probability that a data value is less than 22. Okay, so let's just go through the steps first, find this probability, and then once we have it, I'll show you how to draw, label, and shade the bell curve. I think I should have comments here. Draw, label, and shade a bell curve. Okay, so we'd say, all right, to find this probability, we recognize the data value is x. So here x equals 22. Once I know x, mu, and sigma, I calculate the z-score. So in this case, z equals x minus mu over sigma, 22 minus 19 over 5. What that turns out to be 3 over 5, which winds up being 0.6. Usually our z-scores are not so clean and neat, but I wanted it to be for this example. Okay, then to find the probability that the data value is less than this z-score, well, what do we need to do? Find the probability that z is less than the z-score we just calculated, 0.6. And of course, at this moment, I will look to my table of z-scores, and I've done it already. 0.6 tells me a probability of 0.7257. Okay, so that's the answer to the question. But now I want to do this drawing. How does that work? Okay, here's what you'll do. See if I can get it centered here. So you'll draw a bell curve, draw that line, right, and then draw that curve as best you can. You don't have to be an art major or minor. Um, if your bell curve isn't all nice and symmetrical, it's not perfect, that's okay. But draw a bell curve. At the center of your bell curve, you want to put the mean, right? Our mean was 19, so let's put that right at the middle. You also want to indicate the x value. So our x value was 22, so I'm going to put that up here. Don't worry about exactly how far or near the 19, just put it somewhere above 19. And now we're going to label, we've kind of labeled things already, but now we're going to shade it. So I'm going to draw a line right there at the data value 22. And I'm going to shade everything less than, right? We're doing a less than in this problem. So everything less than that line inside the bell curve gets shaded. Okay. And I'm really going for it here, shading underneath. And then I'm going to represent the probability I just found. So this shaded area represents 0.7257 probability. You could also write 72.57% there if you prefer, or you might just write it in the decimal form. And that's it. That's your drawing, your labeling, and your shading. So if you've got 19 here and 22's out there, this represents 0.7257 probability. I want to do just one more because not every problem you see is going to be a less than. So I've got this one very similar, same setup, but now let's find the probability of being more than 22. Okay, but I'm still going to keep the same mean and standard deviation. I'm still thinking mu equals 19, sigma equals 5. So I would just go ahead, that's my x again. Well, it's the same x that we had in part A. So I would end up calculating the same z-score, 0.6, right? We would be the same formula with all the same numbers. The only difference is we're doing a more than now. So what comes next? Well, if it's a more than, then I want the probability that capital Z is greater than the 0.6, right? And if we're finding the probability that Z is greater than the 0.6, the way we actually go about finding that, we do a complement, 1 minus this probability that Z is less than 0.6. Hey, we already found that number a moment ago, but we can write it out again. That was 0.7257 for that probability there. So we can do 1 minus that and get our answer to this example. Turns out to be 0.2743. Okay, so that would be the answer to the question, but now we want to make a drawing and shade. So let's see if I can fit all this on the same screen. Okay, that's pretty good. So I'm going to start by drawing a bell curve again, right? Again, at the center, I'm going to put the mean, which is still 19. And my data value is still 22, so that goes up here. And I'm going to draw a line right there. But this time, how am I going to shade? Since it's greater than, I want the probability more than 22. I'm going to shade everything up here, more than 22. And then I'm going to put, maybe if you don't have enough space, right, arrows work nicely. This is 0.2743. So there's my drawing, my labeling, my shading. There you go. You're also going to get questions, that have a between. If you get a between, then you would indicate both of your x values and just shade what's in between. There are also percentile questions, so you'll have to think about how that shading works. Okay, that is the introduction. Of course, any questions, you can most certainly stop by office hours. Good luck.